Hey guys, today's video is about proximity measures. I'll talk about proximity measures for ordinal data. The concept is related to the normalization and proximity measures for numeric data. So if you haven't watched the videos for numeric data, which is proximity measures 3.1 and 3.2 in my channel, please go and watch them first. Alright. Ordinal data is data with meaningful ordering among values, or you can call it ranking. The proximity measures for ordinal data are exactly the same as for numeric data, since we are going to transform the data to numeric first. Why do we transform the ordinal data? To digress a little here, you should always ask why when you do specific operation on your data. You don't just say, I want to take the square root of data for no reason, since a lot of times you may improperly distort the data. Okay, so we transform the ordinal data because of its data nature. Some pairs of values are closer than the others, and we can use numbers to present the differences in the magnitude between the values. What I mean exactly is that by assigning the ranking to the stats, we can use any number we want, and the numbers don't have to be consecutive. How to convert the data in practice is quite similar to the normalization process, which I've talked about in video 3.1. We use the formula here, and we normalize the attributes one at a time. RIF is the rank of a particular object. MF is the maximum ranking assigned to values within an attribute. ZIF is the converting numeric data. Let's look at an example. We have 4 people with different opinion, disagree, neutral, and agree. We now assign ranking to each stat. Disagree to 1, neutral to 2, agree to 4. Did you notice the differences in the magnitude between values? Neutral and disagree is different by 1 unit, but agree and neutral is different by 2 units. It might be because agree is a strong opinion that we want to give it more weight. The point is, we can define the ranking by ourselves and combine the ranking with the meaning of a certain attribute in the real world. Now we have the ranking. The next thing we do is to normalize the ranking to the range of 0 to 1. And we use this formula to achieve our goal. MF is the maximum ranking assigned, which is 4 in this case. Basically, disagree is 1 minus 1 divided by 4 minus 1, which is 0. Neutral is 2 minus 1 divided by 4 minus 1, which is 1 over 3. Agree is 4 minus 1 divided by 4 minus 1, which is 1. And voila! We have the normalized ranking of each attribute. One thing you might notice is that only RIF is changed when we calculate the ranking for each stat. So the formula is not that difficult, right? Second, we assign the lowest ranking to disagree and the highest ranking to agree. After normalization, the disagree becomes 0 and agree becomes 1, which again proves the normalization works, because these stats are supposed to be on the extremes of new range. Now we put the ranking back on the table. Then we can apply any proximity measures for numeric data, but we use Manhattan distance here. Manhattan distance is just a special case of Minkowski distance with h equals to 1. So the dissimilarity between Amy and Patrick is just the absolute difference between their values, which is 2 over 3. The similarity between them is 1 minus the dissimilarity, which is 1 minus 2 over 3. So, that's pretty much it for ordinal data. We've discussed the proximity measures for basic data types, and we'll talk about cosine similarity next time. Thank you for watching my video, and I hope you enjoy it.